Hello fellow mathletes, today we will use the limits to prove some important identities. So first of all, if limit n tends to infinity and 1 plus 1 over n times 1 over n raised to the power n is equal to e. Let's dig into that proof. I've already solved it, so it won't be very difficult to follow. Now we will use the binomial theorem to expand this 1 plus 1 over n raised to the power n. So 1 plus n into 1 over n plus 1 over n squared times n into n minus 1 times 1 over 2 factorial plus 1 over n cube times n into n minus 1 into n minus 2 multiplied by 1 over 3 factorial. That's the binomial theorem. Now this n will cancel out 1 1, and now what I've done here is I've separated this n squared into two terms. I've made two terms out of it. First n will be used to divide this, and second n will be used to divide this n minus 1. So it becomes something like this: n divided by n, n minus 1 divided by n. And the same I've done with this third term, n cube, 1 over n cube times n into n minus 1 into n minus 2 or 1 over 3 factorial. So that's what I've done here. Now if you observe closely, what it does is it makes these terms into something like this: 1 into 1 minus n, 1 minus 1 over n, and 1 minus 1 over n, 1 minus 2 over n. And similarly for the fourth term, 1 minus 1 over n, 1 minus 2 over n, 1 minus 3 over n. Now if I take the limit n tends to infinity, what it does, it eliminates all these terms, these terms, because something over infinity is equal to 0. So that's what happens here. 1 plus 1 plus 1 minus 0 into 1 over 2 factorial plus 1 minus 0 into 1 minus 0 into 1 over 3 factorial, and so on. So it leaves us with this 1 plus 1 plus 1 over 2 factorial plus 1 over 3 factorial plus 1 over 4 factorial plus 1 over 5 factorial. Now this series, this infinite sum tends to the value of e. It approximates to the value of e. So we can conclude that 1 plus 1 over n raised to the power n is when limit n tends to infinity is equal to e. Now in the same now we will prove that 1 plus n divided by times 1 plus n raised to the power 1 over n is when limit n tends to 0 is equal to e. So what I have done here is I simply substituted, I took the reciprocal of this here. So let's let n is equal to 1 over x and x is equal to 1 over n. So when n tends to 0, x tends to infinity. So I've replaced n with 1 over x. So it becomes exactly like this expression, and this limit n tends to 0, it becomes x tends to infinity. So it is exactly this expression. So, and we've already proven that 1 plus 1 over x raised to the power x when limit x tends to infinity is equal to e. So that's it.